Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akimi bin Muhammad Jeffrey, and today I will present about the compaction trend estimation and application to sedimentary basin reconstruction. For the next, first of all, today I will talk about the introduction, which is basin overview and input of the basin. Next, the objective and methodology of this subject, which will conclude the stratigraphy of basin and transport, which is transportation and sedimentation. Next is result and interpretation, which we discuss about the basin structure and compaction trend. And lastly, we conclude the review paper, which is and recommend how to improve it. Okay, first of all, the introduction, which we of all, basically, the first of the basin is Perth Basin, which the size of the basin is 172,300 kilometer square, and the is developed by the multiple episode of rifting and drifting of the Greater India, Antarctic, and Australian plate since the late Paleozoic, and it filled with the sediment and sedimentary rock from Cenozoic and Proterozoic, and the unconformity formed during the breakup of the Greater India and Australia Antarctica, and also this basin also consists of thin coastal clastics, chalks, limestone, and marls, and it also consists of thin also deposit after the deltic, fluvial, and shallow marine deposition from the Paleozoic to the lower Cretaceous. So for the next slide is the next basin we will introduce is the Vina Basin, which is located between Eastern Alps and the Pannonian Basin system, and it also overlying fold and thrust belt, which is located between the Eastern Alps and the Western, which is the Western Carpathians. And the Miocene development consists of two phases, which is lower Miocene pitchback system and the middle to Miocene to upper Miocene pull apart system. And the basin filled with the alternating shales with minor conglomerates and marls. So, for the objective of this study, first of all, is to achieve the understanding of model of sedimentation system and evolution of basin history. Next, to evaluate and interpret with the depositional setting of the basin, and to estimate the compaction trend of the basins. So, moving on to the methodology, as you can see, this is the flow. You will be using the MATLAB to compute the data of the basin, and also next slide is the stratigraphic setting stage consists of sedimentation profile. This picture shows the trend of each stone that compute in the basin system, which is sandstone, shale, and carbonate, which is show the porosity over the depth over porosity in the basin. As you can see on the picture C, the stage by stage process of the basin and the deposition can be applying. First of all, in stage 1, is the deposition of the layer A. Stage 2 is the compacted layer A and the thickness buried and loaded by the sediment of the basin B, of the layer B. And the third stage, which is a compacted layer A and the reduce of the thickness buried by the B and the layer C, which is overburden the layer A and create fault. Okay, for the next is for the result and interpretation. As you can see, for the first one is the compaction trend plot for the curve basin. As you can see, in the site U14959, the carbonate and cellulose post breakup unit is decreased in porosity over the depth. And also the hookman also is the trend is decreased over the depth, and also in the side, if we compare two of the data, you can see the linear line of the hookman and um, eh, the quadratic line of the side U14959. So for the next is the is another type of trend plot, which is by using the edge over depth, we can see that if the edge increase due to the depth increase, you can see when the sediment is over 350 meter, the edge of the sediment is older than the upper one. For the thickness over depth, as you can see, the thickness below 300, the thickness is decreasing. When meet to the 250 to 150 meter, the thickness is bigger than the older one and the younger one, and the trend is increase. The trend is same, is increased due to the time. Next is the depth of the rate of sedimentation. As you can see, the most sedimentation rate is in the 100 and to 150 meter as compared to others depth. And the thickness of the as the thickness over the edge, the thickness that have the bigger thickness is in the layer of 15 million years ago until the 35 million years ago. And also the rate of sedimentation over the edge is in the upper one in 5 million years ago. Next, for the Vina Basin, the depth is proxy important for the compaction driver, and it is such as effective if they have stress and temperature. And the formation is also affected by the depth and also the pore pressure. When the depth increase, the pore pressure decrease because the compaction increase due to the overburden layer in the upper layer. Next, as you can see, the sedimentation rate maps of compactation unit, the 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 value of the meter in the compacted layer and the compacted layer. in the compacted layer, the highest is in 1,600 meter. For the compacted layer is 1,200 meter. As you can see, the thickness reduce if the layer become the layer below compacted. The the layer will be compacted if the time increase. Okay, next. As you can see also is another type of data in the 15.97 million years ago. The highest is the 2,000 kilometer, and the the thickness drop to 1,600 meter in 12.83 million years ago, as the layer have been compacted, but the sedimentation is still running. As you can see, it is also compacted until 9.8 million when it is lasted 1,600 million kilometer, and until the present they have only the bigger size of the land as the thickness variation occur. Also, the compaction trend also can determine by the type of rock, as you can see, and in the red line U14959, as you can see, this is the compare trend. The U1459 is from the Basin, and the carbonate of South Florida Bay is from the Basin. And also the subsidence curve is decreased through the decrease of the time. Next. So as the conclusion, the compaction trends can be examined by thickness distortion of stratigraphic units. Second, the characteristic of study area, geological history and study area by handling uncertainty. And the visual of the map can be improved by the understanding of the basin construction. And next, for the last one, the recommendation is we can improve the result by obtain the best fit line in the result and analyze the data carefully, and also understand deeply the history of the burial and sedimentation of the basin. That's all from me. Thank you.